Now, in this experiment, we are going to verify Ohm's law. And before we state Ohm's law, or before we look at the specific steps to be followed, I'm going to introduce the apparatus that we are going to use. And one of the most important pieces of apparatus that I want to introduce here at this point is referred to as the breadboard. This one is a breadboard. It comes with a simple Arduino circuit. It's simply a piece of plastic that has a grid here, holes. You can see these holes make a grid. Below these holes, we've got strips of copper. For example, you can see this red line here. It means that the holes which are just next to the red line belong to that line there. Now, what do I mean? Below these holes here is a strip of copper. So if you push a wire through one of these holes, that wire is going to make contact with that copper strip. Similarly, along this blue line here, below it is a strip of copper. Again, pushing a wire through one of those holes, that wire is going to make contact with the copper strip. For example, these two wires are coming from my battery. My battery has an EMF of 9 volts. So this is the positive terminal. This one here is coming from the positive terminal of the battery, and this one is coming from the negative terminal. So it means that if I wanted to connect a voltmeter, I can connect one terminal to this point here, to the positive terminal, the other one to this other terminal, and I'll be able to measure the EMF of the battery, or the terminal potential of the battery. That is what I've done over here. This wire is connected to the positive terminal of the voltmeter. This one is connected to the negative terminal of the voltmeter. And you can see from this meter over here, it shows that the EMF is 9 volts. Exactly 9 volts. So I'm using two cameras. I'd like you to look closely at the breadboard to be able to understand what I'm connecting. And at the same time, I'd like you to look at the meter in order to confirm the readings all by yourself. So the two terminals of this meter are connected. The positive terminal goes here, the negative terminal goes here. So I can be able to change that connection. For example, if I were to move this wire from that hole and I disconnect, you can see that the reading goes to 0. I can move it to a different hole altogether, somewhere there, and you can see the reading comes back. So it really does not matter to which one of these holes I do the connections. I can do the connections to any one of these holes so long as it's along this line here. Similarly, I can do the same to this one here. So the breadboard helps us to connect or to do these connections very fast. So at least now I know how I can connect my battery, and I know how I can measure the EMF from the battery. Now let's see what we need in order to verify Ohm's law. I hope you're able to see my cursor. In order to verify Ohm's law, we need a metallic conductor, a resistor. So this is the resistor that I'm talking about. I need that resistor. I need to connect a potential difference across this resistor, and I need to measure that potential difference. So I'm going to have the voltmeter connected across the resistor. And I need to measure the current which flows through that resistor. So I need an ammeter. Further on, I need to measure, or I need to control this potential drop or potential difference across this resistor, and I will need a rheostat in order to do that control. I'm going to show you all this in a moment. And of course, I need a source of electrical power. and that is the battery, the 9-volt battery that I'm using. And here is my connection. Of course, I can put a switch somewhere around here. This is the resistor. So I'm going to vary the potential drop across this resistor using this rheostat. And then I'm going to get different values of voltage and current. Potential drop in volts, current in amperes. So let's assume I'm going to get about 6 volts. So I need you to draw this table in your exercise books and also draw that circuit the way I've drawn it there. And we are going to take about, these are 4 readings. We can take about 6 of them in order to be able to plot a graph. So you need that table so that as we make the readings over here, of course over here, you can be able to see, I've just shown you the voltmeter. In a moment, I'm going to include an ammeter there so that the two of them can be side by side, and I'll be able to measure the voltage and the current. The voltage across the resistor and the current through the resistor. Now let's go back to the breadboard so that I can show you this rheostat. So probably you have seen a gadget like this. It usually has 3 terminals, 1, 2, 3, and it got a dial here that you can turn, using a screwdriver, or even using your hand. You can be able to turn it like that. But because I have moved my camera very close to the breadboard, I don't want to obscure anything. That is why I'm using these prongs here to be able to show you how it looks like. So it has 3 terminals. So for us to be able to use it as a rheostat, I'm either going to use this terminal and this one, or this one and this one. Whether I'm using this and this, the middle terminal must always be used. Let's have a closer look at how this one looks like in terms of a diagram. So actually what I've just shown you is referred to as a potential divider. It is a 3-terminal device. The terminals at the ends are this one and this one. And then there is a terminal at the center. This terminal can be able to move to the right and to the left. In order for me to use it as a rheostat, I can decide to use this terminal here and this one, so that when this terminal moves this way, the resistance reduces. When it moves this way, the resistance increases. Remember, all I need is a resistor whose resistance can be varied. In fact, this particular connection here could be drawn like this. This wire here would remain the same. Then the resistor is like that. And then this terminal here can be drawn here. Put an arrow there and that. So you find that this terminal will not be used at all. So this terminal is actually this one, so that when I rotate the dial, it either moves this way, increasing the resistance, or this way, reducing the resistance. So that is what we are going to do. The other thing that I need to introduce is the resistor. This is such a resistor. They are referred to as carbon resistors. They've got colors, and for now we are not going to bother ourselves what those colors stand for, but then later on we should be able to determine the resistance of a resistor just by looking at the colors. For now, this is the resistor that I'm going to use over there. So I've introduced my rheostat, I've introduced the resistor, and over here I'm going to add another meter so that we can read the voltage and the current. And let me do that connection, and then I'll come back to you. Now, in this circuit, there are a few changes that I've made. I've realized that it may not be possible to use the analog ammeter, because the analog ammeter actually is not very sensitive. So I've changed that, and I'm using a digital ammeter, and the scale I'm using has got a maximum of 200 milliamps. 200 milliamps. So the reading that you can see there is 6.8 milliamps. So whatever readings you're going to take over there will be in milliamps. So we are going to change a few things on our table. So on our table, this reading here, let's just change it to milliamps like that. So I'm going to now vary this resistance. I'm going to start with the smallest value of the potential difference. So I keep my eye on the meter, and when it reads just one division from 0, and remember I'm using a scale of 0 to 15, so I'm using the upper scale, and on the upper scale that is 0.5 volts. 0.5 volts. So let me again change it carefully until I get there, 0.5 volts, and the current is 1.7 milliamps. So we go to our table, we record that value, 0.5, we get 1.7. Let me go to 1 volt, turn it slowly till I get. You have got to be very careful when you're doing experiments in physics. You've got to make very slight. You've got to be very careful, because if you just rotate the dial anyhowly, you're going to get a pointer which is going to fluctuate. That is 1 volt. 1 volt, 2.8 milliamps. So this is 1.0, 2.8 milliamps. Let me go to 1.5. So that is almost 1.5. Here's exactly 1.5, 5.0. So 1.5, 5.0. Let me go to 2 volts. 2 volts, 6.4. 2.0, 6.4. Let me go to 2.5. 2.5 there, and I have 8.5. Lastly, I want to go to 3 volts. It appears as if it may not be possible to get that kind of voltage from there. Just try one more time. Not possible to get that voltage. It appears to just to reach 2.5 volts with 7.6 around there. So at least I've gotten some values that we can use to plot a graph. So with those values, I'd like you to plot a graph of current on the y-axis versus potential difference on the x-axis, and then you draw your best fit line. And then now we are going to use the graph that you will draw to state Ohm's law and discuss other aspects of this experiment.